Here's our first problem. Write 5/8 as a fraction with denominator 24. So I'm going to start with 5/8, and I want to rewrite this as a fraction with a denominator 24. Now with fractions, there's only two properties that we have for fractions. We can multiply the numerator and denominator by the same number. It won't change the value of the fraction. And we can divide the numerator and denominator by the same number, and that won't change the value of the fraction. As far as fractions goes, that's it. Those are the only two properties of fractions. So to get from 8 to 24 with multiplication, I need to multiply 8 by 3 in order to do that. Since I did that to the denominator, I do the same thing to the numerator. 5 times 3 is 15, and I see that 15 24ths then is the same as 5/8. Because what I've done really is multiplied the fraction 5/8 by the number 1. That's another way to look at this property of fractions. So if I take 5/8 multiplied by the number 1, it doesn't change the value of that fraction, but it gives me an equivalent fraction that has a denominator of 24. Now later on when we add fractions, you'll see that that's an important little skill to be able to have when working with fractions. Here's another problem. Let's find the opposite, reciprocal, and absolute value of -3. Well, the opposite of -3 is 3. It's the number that's the same distance from 0 on the number line, but in the opposite direction. So -3 is to the left of 0 on the number line. Its opposite is +3, which is 3 units to the right of 0 on the number line. The reciprocal of -3 is -1/3. Now, we haven't covered multiplication with negative numbers yet, but you'll see when we do, a negative number multiplied times another negative number gives us a positive number. And 3 times 1/3 is the number 1. So reciprocals are numbers that multiply to 1. And now the absolute value. The absolute value is the distance -3 is from 0 on the number line without regard to the direction it is from 0. That is always a positive value. So the absolute value comes out 3. That's the distance that -3 is from 0 on the number line. So vocabulary for algebra, just starting out here, you need to know what the opposite of any number is, the reciprocal of any number, and be able to find the absolute value of any number. Here's our next problem. Let's place either less than or greater than one of these two inequality symbols correctly between these two numbers right here. Well, inequality symbols always point to the smaller of the two numbers. So the question really is, between -3 and -7, which one of these numbers is smaller? Well, it's the number that's more to the left on the number line. And -7, if you look on the number line, is to the left of -3. So -7 must be the smaller of the two numbers. So that's the correct inequality symbol to use. So it's not really so important that you remember that this is less than and this is greater than. If you remember that inequality symbols always point to the smaller of the two numbers being compared, then it'll be easier for you to use them. So when it comes to numbers on the number line and you're comparing two of them, the one on the left is always the smaller of the two numbers on the number line. Let's look at our next problem. We want to simplify, and here we have an expression that involves absolute value. Absolute value will work in the same way that parentheses do. We need to simplify everything inside there first, and then we'll take its absolute value when it's down to a single number. So inside the absolute value symbols, I have to go inside the innermost parentheses first. So I have 10 minus absolute value, 7 minus 2, times the quantity 5 minus 3, which is 2. Close my absolute values. Now I'm still working inside the absolute value symbols. 7 subtract 2 times 2 is 4. I need to multiply before I subtract. 7 subtract 4. I still can't take the absolute value yet because I only know how to take the absolute value of a single number. So I can't do anything with these absolute value symbols until this is down to a single number. I have no properties for absolute value or anything else. So let's continue. 10 subtract absolute value. 7 subtract 4 is 3. Now, the absolute value of 3 is just 3. So this is 10 subtract 3. Not too much of a big deal there. 10 subtract 3 is 7. So absolute value, when they're in a big expression like this, they work the same as parentheses in that they group the things inside there together. So I'm inside the absolute value symbols. I have to go inside these parentheses, work my way out until I'm down to a single number inside there, take its absolute value, then I finish the problem. Here's two more problems. Let's multiply. I have a couple of fractions. 1/2 times 3. This is the same as 1/2 times 3 over 1. Any whole number by itself can be thought of as a fraction with a denominator of 1. Now, when I multiply fractions, I multiply numerators. 1 times 3 is 3. And I multiply denominators. 2 times 1 is 2. So the answer there is 3/2. That's an improper fraction because the numerator is larger than the denominator. But in algebra, it's actually better to leave it as an improper fraction than it is to change it to a mixed number. So we'll leave our fractions in this form right here. It's in lowest terms, and it's an improper fraction. That's fine with us. Here's another one. 3 times 1/3. 3 is the same as 3 over 1. 3 times 1, when I multiply the numerators, is 3. 1 times 3 is 3. And then 3 over 3 is the same as the number 1. So the numbers 3 and 1/3 are reciprocal, so we know it comes out to be 1, but I'm going to write it like this so I can see it as a multiplication problem with fractions. 3 over 3 is the same as the number of 1. So there's a look at some of the problems that we can work and some of the vocabulary that's associated with the real numbers, the set of numbers that we're going to be using throughout this course.